In addition to the Rip and Insert Bends features, SOLIDWORKS has a tool that automates the process of converting existing parts into sheet metal parts. The tool's called Convert to Sheet Metal. Here, I have a solid part which I would like to convert to sheet metal. I want all of the faces to become flanges except for the cylindrical face and the back top face next to it. I've also created a sketch on the top of the part where I'd like to create a rip so the part is symmetrical when it's unfolded. This is the Convert to Sheet Metal icon. It can also be accessed through the Insert Sheet Metal drop-down menu. When the Property Manager appears, the first selection window asks to select a fixed face as a starting point. The face you select will remain stationary for the flanges to be bent from. I'll select the bottom face. And when I do, you'll immediately see a preview. Next, I'll define the sheet thickness, and notice which side of the face the thickness is being applied to. I can use the Reverse Thickness checkbox to switch it from the inside or outside of the face. Notice that this part is basically being treated as a surface body. The Convert to Sheet Metal tool uses only single faces or surfaces to establish where the surfaces of the sheet metal flanges will end up. That's also why a surface body would act the same way as a solid body when using this Convert to Sheet Metal tool. Below the sheet thickness, I can set the default radius for bends in the part. The next selection box is for defining bends in the part. The easiest way to do this is to start from the fixed face and work outwards. I'll select the 4 edges of the fixed face. And while I do this, SOLIDWORKS will automatically show ripped edges of where the flanges will meet. In the graphics area, you'll see flags representing the different rip and bend edges. You can edit the values of the radius or gap of specific edges throughout the part. The default gap distance is found just below the Rip Sketches box. You can define the gap distance, overlap ratio, and corner type, similar to what we saw in earlier lessons with other sheet metal features. Notice the preview updates as I toggle the different options here. Next, I need to add a bend on this top edge. When I do, the preview shows the flange extending all the way across the part. In this example, I actually want 2 flanges with the rip in the middle. To do this, I'll activate the Rip Sketches box and select the sketch that I want to use for the rip. The preview updates to show the flange extending up to the sketch. I can now activate the Bend Edges box again and select the opposite edge. The preview updates and looks the way I want it. It's not necessary for every edge to be defined as a rip or a bend. The cylindrical face and the small top face will not be used in the sheet metal part. It will simply be left as open space on the sheet metal part. And before I click OK, I'll set the Auto Relief section at the bottom of the Property Manager. I'll set it to rectangular and 0.5. Now everything looks good, so I'll click OK. When I do, the solid part is converted to sheet metal part so that it can be flattened, and at this point, I could continue to add more sheet metal features to it. Now before concluding this lesson, I want to show you one more example of a part that started as a sheet metal part in another CAD system and imported into SOLIDWORKS. Notice SOLIDWORKS only sees it as a solid body with a single imported feature and not a sheet metal part. I'll again use the Convert to Sheet Metal tool to add the sheet metal and flat pattern features. I'll select the bottom face of the part for the fixed face. Remember that the thickness is defined from this fixed face. So even though the imported part has a thickness of 2 mm, I can still define the default sheet thickness to a slightly different value. Since this part started as a sheet metal part in another program, it already has a bend radius applied where the flanges meet the base. In the Bend Edges window, I need to select the rounded faces instead of an actual edge like you saw in the first example. So to save time, I can also use the Collect All Bends button to automatically select pre-existing bends in the part. The rip edges and sketches will appear blank since the part is already created with gaps between the resulting flanges. Changing the auto relief on the part will also not do anything since auto relief is already defined in the part. The part looks good, so I'll click OK, and the sheet metal and flat pattern features are added to the part.